All right, we are doing 6-5 today. And 6-5, the beauty of 6-5 is you know it all already, really, because it's just the converses of what we did in 6-4. So this should look very familiar to you. There's 3 theorems. Remember yesterday we did 3 theorems as well. We did the diagonals of a rhombus, which was 2 theorems, and we did the diagonals of a rectangle, which was 1. Same thing today. It's just now it's more the converse of those original theorems. So I'm going to write this out just to kind of condense a little bit what we're doing. We're going to say, maybe I'm not going to condense. I don't want to confuse you. Okay, we're just going to write the 3. The first one is this. If a diagonal of a parallelogram, if the diagonals, my bad, of a parallelogram are perpendicular, okay, if the diagonals of a parallelogram are perpendicular, then what is true? It is not a rectangle, it's a rhombus, right? So if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. Okay, why don't I have to say or square? Then it's a rhombus or square. Do you know, Randy?
Because a square is a rhombus.
Right. So you don't have to say both, because if it's a rhombus, it is also a square, okay? So you can just say the overarching, it's a rhombus. So that's the first one. The second one says, if one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a what?
Rectangle or square.
No. Which one bisected the angles?
I thought it was a rectangle. I was going after that.
Yeah. It's the rhombus, right? The rhombus is the one that bisected the angles. So then it's a rhombus, okay? And again, you don't have to say rhombus or square, because a rhombus is a square is a rhombus. So you can just say a rhombus, and that covers squares as well, okay? So those are the 2 about rhombuses. And then the third one, God bless you, says this. If the diagonals of a parallelogram are congruent, then it's a what?
Rectangle.
Then it's a rectangle. Then the parallelogram is a rectangle. Okay, so those are the 3 theorems we're going to be working off of. So I'm going to give you, kind of like we did at the end of the lesson yesterday, I'm going to give you some pictures, and you tell me what we're working with, okay? And why it is what it is. So first example, we're going to say rhombus, rectangle, or square, and why. All right, so our first picture looks like this, and the markings we have are those. Okay, so we're saying this is a parallelogram, okay? Everything that I give you here will be a parallelogram, so you don't need to worry about the fact that you don't have markings for a parallelogram. I'm telling you, it's a parallelogram, okay? So from this picture, if this is a parallelogram, what type of parallelogram is it?
A rhombus.
This is a rhombus, right? Because it bisects an opposite pair of angles. Oops. Okay, so we would say this is a rhombus. It bisects opposite angles. Okay. What would this one be? And just be careful with these that you don't just go, oh, it's because it looks like I can make every one of these look like a square, right? And it's not necessarily a square. It might be a square, but it doesn't have to be a square. So just pay attention to your markings. Let's say those are the markings I give you. So you know a few things about your diagonals. Take a look at that. All right, raise your hand if you think this is a rhombus. Raise your hand if you think this is a rectangle. Best term, okay? Raise your hand if you think it's a square. Okay, so you're right in that it is all three of those because it's a square. For these ones, I didn't say this. You want to give the most specific name that you can. So this one is a square. The reason being, okay, this box telling us it's 90 degrees tells us it's a what? That makes it a rhombus, right? Because your diagonals are perpendicular. Okay. These markings saying that those four are congruent, that means the whole diagonals are congruent, right? So that makes it a rectangle because it has congruent diagonals. And whenever we have enough to say it's a rhombus and a rectangle, then we can say, put them together, it's a square. Okay, so your best answer here is that is a square. Questions on that? All right, how about this one? What would that be? Yeah, Daniel.
A square, because it has the four congruent halves of the diagonals.
It does. It doesn't have to be a square, though. What would that be? Randy, what is that? It's a 7. Sorry, I always write my 7s with the little bar. So it's a 7. My bad. Yeah.
So then a rectangle?
It's a rectangle, right? If the diagonals are congruent, so you have a 14 and a 14, if your diagonals are congruent in a parallelogram, that is, then it's going to be a rectangle. So we would say this is a rectangle because you have congruent diagonals. Okay, questions on that one? All right, how about this one? So we have a 90-degree angle there. What's that going to be? If this is a parallelogram, which it is. Yeah, Gracie. That would be a rhombus, okay? It might be a square, but we don't have any information that tells us it's a square. The only information we have is that those diagonals are perpendicular, and that would make it a rhombus. Okay, so the best name you can give it is a rhombus because it has perpendicular diagonals. Okay, questions on that? Okay, so I have two examples where you need to find a value of x to make the figure, whatever we're trying to make that figure be. And then I got one example where you're going to come up here and help me. At least 4 of you are. So we'll get there in a second. The question is this: for what value of x is parallelogram ABCD a square? Okay, and here's what we have. This is A, B, C, and D. This angle here is 6x plus 6. And these are marked congruent. Okay, so I'm telling you in the problem, it is a parallelogram. If I want this to be a square, first of all, we know opposite sides in a parallelogram are congruent. So even though they only gave us 2, we know all 4 sides are congruent. What do we have to do with that 6x plus 6?
It has to be set equal to 90 degrees.
Right, it has to be 90 degrees if this is actually going to be a square because our diagonals have to be perpendicular, okay? So we would say 6x plus 6 equals 90, and then just solve that. So 6x equals, we're taking away 6, sorry. 6x equals 84, divide by 6, and you get x equals 14. So if x is 14, then this figure would be a square. Okay? What are you going to do with this one? We want this one to be a rectangle. And here's the picture we have. Sorry for the squiggly lines. So you have 5y plus 3 and 7y minus 5. In order for that to be a rectangle, what does the value of y have to be? What do you have to do with that? Yeah, Jerry. Set them equal, right? The diagonals have to be congruent, and the diagonals have to bisect. So that means all 4 of these are going to be congruent pieces. So we're just going to say 5y plus 3 equals 7y minus 5 and solve from there. So take away your 5y, you get 2y. Add your 5, you get 8. Divide by 2. So y would be 4. Okay. Any questions on those? So it's going to look a lot like yesterday's stuff, right? It's just the converses of what we did yesterday. The last thing we're going to do, I need 4 people for. Come on up. It's not scary. Because the rest of you are actually going to help the 4 people. But I need 4 people. Come on, people. Randy, come on up. This is Randy, by the way. He goes to my church. Hi. He's checking out Valley for next year. Seriously? 2 people. This is not hard. The class will tell you what to do. Okay, so here's the deal. I just want to show you what we're starting with here. Okay? These 2 pieces of material. Okay? And they're going to each hold a piece to make a rectangle. So I want to know if each holds a piece and they need to make a rectangle out of this, what do they got to do?
We have to make it, because they're at the top, and then we have to just all four of them to make corners, and then go like this.
How do you know that's a rectangle?
Well, it's not, because it's made out of fabric, so it doesn't have straight lines.
Okay. But I can pull this straight.
Yeah, but this is kind of wobbly.
Right.
You see what I mean?
So is there a way that you could use these 2 pieces to make a rectangle?
Yeah, we could cut them into equal lengths
And do what with them?
and put them on the ground together.
You don't have to do that.
We have 4 people up there for a reason.
Yes.
Put
4
them into
people.
4 pieces and everybody
didn't
holds a piece and
actually
put
let
them
other
together.
people help.
No. Hey. Nobody else is giving input? Yeah, what do you think?
Each person holds one end of two pieces. And we stand at the
And you
corners
do.
of the rectangle.
Okay, but do we know it's a rectangle then?
If we're
Oh.
standing at the corners.
We're gonna put diagonals.
There you go. Okay, so if we have diagonals, what do we know about our diagonals in a rectangle?
They have to be,
They have to be congruent. So how could you make these congruent?
by cutting them, lining them up, and then ripping it.
Okay, so tear that off. Okay, so you have two congruent diagonals.
And now
How are you gonna make it a rectangle?
I go here, and we have to find the midpoint of both, which is here.
Mhm.
Oops, sorry. And can we bolt tight? And then we each grab an end.
Ta-da. Is that a rectangle?
It is the diagonals of a rectangle.
True point. It would make a rectangle if we connected here to there, to there, to there, right? Does that make sense? So your diagonals have to be congruent, but to make it a parallelogram, you have to bisect them to make sure that it's equal all four of those. You would have a rectangle. So it's not the same rectangle that someone else might come up with, but it's a rectangle. Thank you guys.
What are the other pieces for?
I got 3 more classes.
Oh, can we throw this away?
Yes, you can.